Okay, 6.11, kind of the last lesson in this unit. Then we'll be doing a lot of review for the test. Okay, the ideal length of a certain length nail is 20 millimeters. The actual length must be within 0.4 millimeters of the desired size. Write an inequality that describes a range of the acceptable lengths of the nail. This is how you do a range problem. You make a number line first, but you don't put 0 in the middle, okay? You put the ideal length, 20. 0 is not a part of this. Then you make ticks on both sides. You got the maximum and the minimum. Here's how you find it, okay? Put your 20, you're going to add, and you're going to subtract. So when it says it's within 0.4 millimeters of the desired size, that means it can be 0.4 more or 0.4 less. So it's going to be 20.4 and then 19.6. So I plot those, 20.4, 19.6. Now when you graph, they're always going to come in towards each other because that's what a range looks like in between them. Now pick a letter. Don't put 20, you pick a letter, okay? Pick L. If you pick X, that's fine too. 19.6, 20.4. You don't write 20 at all on this. You eat the maximum, but you never eat that, okay? Because and that's the answer, okay? You don't need to write any more. But if, let's say I'll pick something in between there. Let's pick 19.8. Between these two, that's bigger, it eats him. Between these two, that's bigger, it eats him. Okay, it's a slick little way to arrange that. Don't do that, but. Okay, next problem. The ideal length of a horse fence is 300 feet. The length must be within 5 feet of the ideal amount. The ideal width is 450 feet. The width must be within 10 feet of the ideal amount. Write inequalities for the range of both the length and the width. Now you have two ranges defined because it says the length and the width. Okay. What's the ideal length? 300. What's the ideal width? 450. So let's do this one. Okay. So 300, 300. I add and subtract. Okay, it's supposed to be, the length's supposed to be within 5, so that means you add 5 for the maximum, subtract 5 for the minimum. So it's 305 and 295. Okay. Then the range, they come together. Okay. All right, so pick a letter. Since it's length, I'm going to pick L. If you want to pick the letter, that's fine. So if you want to pick a different letter, that's fine. 305. We eat the maximum. We don't eat the minimum. That's the answer right there. Okay. Now let's talk about our 450. So it can go above and below that. That's your width. That's within 10. Okay. So plus 10 minus 10. So 450 plus 10 is 460. 450 minus 10 is 440. So 460, 440. Pick a letter. I'll pick W since it's the width. If you want to pick Y, if you picked X up there, don't pick it again. Pick another letter. Pick Y. I don't care if it's Z. Okay. 440, 460. Eat the maximum, never eat the minimum. Okay. Okay, next problem. A manufacturer is curing metal into rectangles that are 20 inches long and 35.25 inches wide. Each metal's length and width must be within 0.25 inches of the desired size. Write inequalities that describe the acceptable range for the length and width. So again, we need two of these ranges because we're talking length and width. Okay, 20 inches long, so 20 and then 35.25. So let's talk about our 20. We're going to add and subtract. Okay, it says both of them must be within 0.25. So I add 0.25 and I subtract 0.25. So it's going to give me 20.25. And then 20 minus 0.25 is 19.75. Circle fillet, connect them. Pick a letter, I don't care which, I'll pick a length, okay? L. If you want to pick Z, I don't, W, whatever, okay? So 19.75, 20.25. Again, you don't write the 20 anywhere in this answer. I mean, you use it, but then you don't use it. You use it, but you don't write in your answer. Eats a maximum, won't eat the minimum. And that's how a range inequality looks. That's applied to real life. Okay, now let's do the other one. You got 35.25. You're going to add and you're going to subtract. Well, since they didn't give me a new within 0.25, I think I'll use again. Okay, so that's 35.5 when added, and this is 35 even. Okay, so we got 35.5, which is bigger than 0.25, because if I put a 0, which I can, it's the same thing. 50 is bigger than 25. Then it's 35. Okay. Okay, combine it. W, I'll put 35, and then I'll put 35.50. Eat the maximum, don't eat the minimum. This thing here is my answer, okay? Okay, last problem. The ideal circumference of a women's basketball is 28.75 inches. The actual circumference may vary from the ideal amount by 0.25 inches. Write an inequality that describes the range of the circumference of the basketball. This is only one range because I just have to do the circumference. Just one thing. It's example 4. Okay, what's the ideal amount? Okay, 28.75. Now there's a maximum and minimum beyond that, so I take 28.75, add to find the maximum. I take 28.75 and subtract to find the minimum. 0.25 is the variation, okay? So if I add those, it's 29 even. If I subtract those, it's 28.5. You can put a 0 if that looks better. So 29. 28.50. This is how a range always works. That's why range is highlighted in the problems. It's going to be the middle number, not 0 though, up below. Okay, pick a letter. I'll use C. If you use something different, it's all good. So 28.50 and then 29. Eat the 29. But never eat the minimum, okay? This is the answer right here.